Hi everybody, my name is Brian. This is my first entry for Hackaday, and this is part of the OpAmp challenge. I'm really excited to make this for you. I'm in Greenbelt, which is just outside Washington, D.C., Greenbelt, Maryland. And before getting to the OpAmp circuit, I'm going to tell you about why I needed this OpAmp circuit. So this is my vehicle. It's an '03 Ford Ranger. It's not much to it. It's about the simplest vehicle you can buy. And I've had it since it was new. It served me really well. I'm going to show you some pictures of it in action, doing some home improvement projects, hauling scrap wood and trash. And here's a picture of it hauling pumpkins. We have a pumpkin festival in our community. And here it is hauling pumpkins to the pumpkin carving site. But recently I got a check engine light on my vehicle, and I got a code reader. That code reader said it was an evaporative emission control system error. And before I go too deep into any of that, I'm going to tell you about what I'm going to talk about today. So topics, you can see them here. Let's start with what is going on. What is the automobile evaporative emission control system? And I'll sum it up for you like this. Gasoline vapors cause smog. They're air pollution, basically. So when your car is off, the last thing anyone wants is your car putting gasoline fumes out into the environment. So when you shut your car off, a vent valve closes and seals your fuel system so those gasoline vapors can't get out. When your car is running, you do not want the gasoline system sealed because you need makeup air to make up the gasoline that goes into the engine. So you need it vented. You need it open to the atmosphere. And what happens, at least in my car, is occasionally while you're driving, it will declare a test condition, and it will seal that vent valve and then use a little bit of vacuum from the engine to bring down the pressure in the fuel system. It'll look at the pressure as it's drawing a partial vacuum on the fuel system and check that the pressure indeed goes down and the system is sealed. If it fails that test, it will give you the check engine light. And if you get that check engine light and it is the evaporative emission control system error code, most mechanics will tell you the first thing to check is your fuel cap. So I'm going to talk about modern fuel caps. Way back in the 60s, fuel caps were basically rubber stoppers. They were plugs. They were not fancy. That just kept debris from going into your fuel port. But modern fuel caps are much different. This one here is designed to stay sealed, except when a moderate vacuum is seen inside of the fuel system, and then it's got a spring-loaded vent release that vents that vacuum and prevents the vacuum from getting too deep, just in case there's a clog in the vent valve or something. You won't have a problem with your car. I won't stall out on you. And when you check your fuel cap, there's two things to check. The first is there's an O-ring here. That O-ring seats on the rim of your fuel port. Check that fuel port is clean and smooth and there's no dents or major dirt or something that would prevent a good seal from this O-ring onto the fuel port. And also check the O-ring in here. Make sure it's in good shape. Make sure there's no problems with it, because if you don't have a good seal of the fuel port rim against the O-ring, you will have an evaporative emission control system problem. Your car will give the check engine light. Make sure it's in well. Sometimes, you're in a hurry, whatever. It's not all the way installed. A lot of them have a click that they are tightened enough, but not too tight. So you can get that seal of the fuel port rim against the O-ring. So the other thing to check, and this one is not so straightforward, is that it actually seals. So I suspect my fuel cap it does not seal, that something is wrong. I don't really have, process of elimination is what makes me think it's this way. So later on, I'm going to test this fuel cap for sealing, and we'll see how well it seals. So I'm going to do that by pulling a little bit of vacuum on it and then using a certain type of vacuum gauge called a Pirani gauge to monitor the pressure as I suck a small vacuum on it and let it drift and see if it refills back to atmosphere. So I'm going to give you a brief bit about Pirani gauges. Pirani gauges are basically resistors that are sensitive really to the amount of gas they're exposed to, and that's a kind of an indicator of pressure. It basically looks at the temperature of the resistor that's exposed to the test atmosphere as compared to two reference resistors that don't change resistance as a function of pressure. So that's the Pirani gauge. And as you can imagine, it is from that bridge circuit, the bridge arrangement you saw, it's a perfect candidate for an op-amp to be a controller. So the circuit I built is basically a two-stage system. The first one basically does the comparison. I've got some time constant on it just because I didn't want it to move too fast. I'm using this from another application that needed that, but this one you could take off the time constant and it would be fine. And then I have a current gain stage. It's basically both in the same package. My Pirani has a little bit of a low resistance, so I needed a fair amount of power capability for it to drive to get the full range of the gauge. Out here is a little circuit I made that if you do it just right, you can use the microphone port of your iPhone to log the pressure. We're not going to do that today, but it's just a little circuit I drew up that does that. I'm really proud of it. It was I learned a lot from how iPhone microphone ports work. So it basically drives the voltage on the resistance. Again, this resistor changes resistance as a function of pressure, and as you actually changes as a function of temperature. So basically this drives it until these two are equal. It's an inverting op amp, and that's the circuit. So now we're going to talk about the actual fuel cap test. So I don't need much of a vacuum. So I use this 100 milliliter syringe on a setup that is very temporary. And it's just the right size pipe to go against the O-ring in the fuel cap. I needed to adapt that to something that I could suck on with the syringe and also with the Pirani gauge. I did do, to kind of rule out any of my equipment, I did pressurize at least some of it and put it in water and make sure there were no bubbles. So I am fairly confident that my seals are good. And let's see what happens. Okay, so let's watch the video of the test. You're going to see the multimeter here is reading the raw voltage to the bridge circuit. It can be converted to pressure, but for what I'm trying to do here, it's not worth it. You're going to see in a moment me pull back, or the result of me pulling back on the syringe, so creating more vacuum. You're going to see that raw voltage drop really as a proportion to the pressure that Pirani resistor is seeing. Here it goes dropping, and then I'm going to let it go, and I'm not going to touch anything, and then you can see it rising back up fairly quickly to atmosphere, which means the gas cap has a leak. So that's your circuit, your system, your setup, your application. I hope you learned something today, and thanks for doing the Op Amp Challenge Hack-A-Day. It got me engaged with the site, and I hope it did for others too.